Hello, welcome again. We are solving some questions of thermal engineering. The topic is gas turbine. Question number 120 from gate to 19 ME-01 is a gas turbine with air as working fluid has an isentropic efficiency of 0.7 with operating at a pressure ratio of 3. Now the pressure ratio of the turbine is increased to 5 while maintaining the same inlet conditions. Assume air as perfect gas with specific heat ratio gamma as 1.4 if the specific work output remains same for both the cases. The isentropic efficiency of the turbine at the pressure ratio of 5 is dash round off to decimal. So this is your isentropic process, okay, and this is your active process. Okay. In the first condition, the pressure ratio is given as 3, okay, and isentropic efficiency is given as 0.7 and gamma is your 1.1. So when we consider isentropic process, then T1 by T2 is equal to P1 by P2 raised to gamma minus 1 by gamma, okay, and pressure ratio is 3, so T1 by T2 comes out as 1.36871 or T1 is equal to 1.36871 T2, okay, and now because actual process is T1 minus T1 to T2 dash, so the specific work done will be here Cp T1 minus T2 dash, okay, and T1 minus T2 dash is equal to T1 minus T2 multiplied by isentropic efficiency, okay, because this is your actual process, actual work done, okay, and this is the idle work done. If you multiply the idle work done by isentropic efficiency, then it will be the actual work done, okay. So now T1 T2 ratio we have found out. So from this we have W in terms of Cp and T1 will be 0.1885 Cp T1, because we will put the value of T2 as T1 by 1.36871 and isentropic efficiency is 0.7. So W is your 0.1885 Cp/T1. So this is equation number 1. So in the second case, okay, same things are applicable, but pressure ratio is 5, and suppose so then T1 by T2 will be here 584 0.4 by 1.4, so that is 1.5837, and T2 will be here T1 by 1.5837, and the specific work done is again same. Formula is same, that is CP T1 minus T2 dash, but here the isentropic efficiency is different, so it is here suppose it is isentropic 2, okay, and T2 by T1 is or T2 is your T1 by 1.5837 in the second case, okay. So now putting the value of T2 and putting the value of isentropic efficiency, also putting the value of isentropic efficiency beta isen 2, okay. So now the work done, specific work done comes out as from this 0.36861 Cp beta isen 2 into T1, okay. So this is equation number 2, this is equation number 1, and this is equation number 2. Now for a same specific work done, as it is given that the work done in the both the specific work output remains same for both the cases, okay. For the same specific work done, equation number 1 and equation number 2 will be equal, okay, or we can say the isentropic efficiency comes out as 0.5138 or 51.138%.